Hey guys, welcome to the start of another restoration series. This time it's going to be Hallicrafters, I think, model T-54. So this is going to be the start of another sprint. I've been doing a lot of triage videos over the last few months. All those sets belong to the same collector. And I need to get them all done by the first week of September. I have 14 sets, something like that, so I need to do about 2 a month. Also, winter is descending. It's going to be in the negative temperatures for the next 5 days or so, so what a great time to hunker down in the workshop, firing up the soldering iron to get the tubes glowing, and work on a TV. Now, I did a Hallicrafters 506 years ago. I can't remember. It might have been before I started doing YouTube videos. I don't know. But I got familiar with this chassis because of that project. But that was a somewhat newer revision. It had a wood cabinet. I think this is the original. It has channel 1. It's in a metal cabinet. It's a little different. Let's dive into it. Yeah, that's right. I said Hallicrafters. The Hallicrafters is in ham radio Hallicrafters, made in Chicago. They did venture into TVs. This is their first TV. 7-inch electrostatic industrial cabinet. They may have used this similar cabinet in other communications devices that I'm not sure about. What's especially unique about it is push-button tuning, including channel 1. And the very last knob here is fine tuning. This is very crusty, so I know we need to work on that, lube it up. Also, these buttons are scraping a bit. Then the top is dented in. I think something got a bit deformed. Maybe somebody stacked a little bit too much on top of this. So they might have a little bit of structural issue to deal with there. And part of the reason I want to dive into this one ASAP is it uses some parts that I don't stock, if the service info is accurate. I pulled out the SAMs for it, but it covers a few variations. They changed the design over time. In one particular area, the IF. The early version uses all octal tubes, I've been led to understand, and later they used some miniature tubes. But also the high voltage capacitors it uses for the electrostatic deflection circuit are values I want to double check on. We'll get to that more in a moment. First I need to figure out how the heck do you open this thing up. I saw there's a hinge across the back, a big old piano hinge. I'm thinking that the top flips up, which would be awesome because then you can get right down in there, replace all your tubes and whatnot. But it's not moving. Now, it might be because it got dented in, or it might be I need to find the secret release. Let's see, we're missing one screw over here. All the knobs are present. That's great. The back is present. Fantastic. The other possibility is that this flips up, but I don't think so. I don't think so. And this would have been the power cord, which is seriously gone crunchy and is just gone. Looks like somebody maybe kind of violently ripped it out of there. I'm not sure what happened with that. A little tough to read the printing on this perforated metal, but let's see. The chassis of this receiver is connected directly to one side of the line. Extra fun. It means it's a hot chassis. One side of this AC line cord goes directly to the inside. They must have some insulation between the chassis and this outside metal cabinet. You don't want to have this entire cabinet going to one side of the AC line. Notice all these knobs are plastic and pretty heavy duty. That's to protect you. Open the top cover completely before servicing. Okay, so apparently it does flip up. Focus, vertical position, horizontal position, width, height. That's all we get. What else? Important, use only clean, dry cloth to clean window in front of picture. Okay. 105 to 125 volts, 60 cycle at power connection. Some such watts. Can't tell if it's 55, 155. But it is heavy. I was surprised to see that it's a hot chassis. I was thinking maybe this variation has a power transformer. This sucker's heavy, so maybe it's just because of all the metal in it, but that's a little surprising. Alright, so how the heck do you open this? I'm going to grab the SAMs because they usually have some disassembly instructions. On the cover of the SAMs, I actually show the portable version, which I think is Tolex covered. So see, it covers a few. I did the 506. I'm pretty sure it's a T-54. I don't see a model designator on the back of it, but we'll poke around. I guess the 514 is what they show. No disassembly instructions on the outside of the folder. Let's get inside. Usually it's on the first page. No. Let's see the power consumption, so 1.05 amps. So yeah, around 155 watts, 130 watts, somewhere in that ballpark. 22 tubes. It's a lot for an electrostatic set. Come on, disassembly instructions. Help me out. No. So you can see what it looks like inside. Does have a transformer. How can it be a hot chassis set if it has a transformer? I have some ideas. We'll find out as we dig through this more. I'm thinking if that's true, it's only a partially hot set. Ah, here we go. Disassembly instructions. Remove 5 push-on type control knobs. Remove 10 screws holding a rear cover. I don't have 10 screws holding a rear cover. Well, that's not going to do us any good. The 5 knobs, I assume they mean the 5 on the front of it, but I do not have any knobs on the back of the set. I've got a piano hinge, so... let me see what I can figure out with this thing. So there's no fastener, there's no catch, there's no screw or anything on the side. I'm thinking it's just stuck because it got smashed in. So, oh, yeah, got the other side. There we go. Oh, I see. There's little catch thingies, little nipples that stick out that go into a corresponding thingy over there. Oh, the cover on the high voltage box is missing. Oh, that's dusty. Yeah, there's a little transformer. Alright, let's get down in there. Look at that. Oh, I love these primitive crusty sets. Alright, first course of action is going to be to get a little vacuum cleaner action going. God, it's so primitive. It's got to be an early generation. And it does have miniature tubes in the IF. We have some octal tubes here. So maybe it's not the earliest. I guess that had all octal tubes in here. And a little transformer hiding on the other side. So what I'm thinking that is, that could be an autoformer for the B+, or it could be filament supply. It might be filament supply for some of the tubes. We also have a nice selenium here. This is a bizarre power supply, as I recall. It has a doubler and a tripler and I think a negative voltage, and then a RF high voltage supply inside that box. The step-up coil. Wow, that's a layer of filth. All right. There is the insane tuning mechanism. So think about an old AM car radio with the push button presets. It says 12 of them. No, 13. Channels 1 through 13. So that's all got to be cleaned and lubed and serviced. There's a pretty good sized speaker. 5x7, 4x6. Mounted on wood of all things, going to this metal cabinet. And yeah, that's some pretty good gauge steel there. That plus the transformer, I guess that accounts for all the weight. Not sure what this little bit of metal's for in the lid. It's supposed to be bent like that, or what that would have done. And of course, 7 JP4 picture tube like these all use. Right. So how the heck do you get this thing out? Oh, interesting. AC interlock up there. So not easily enough. Oh, that's crusty. That is. Oh, that's yeah. So that's why this doesn't have a power cord anymore. Wow, that might be the crustiest power cord I've encountered. That was vinyl at some point, maybe rubber. Oh, there must be fasteners down below. So I'm going to get out a little vac and a soft brush and look for the fasteners down below and see how to extricate this thing, because I want to see underneath the chassis. Well, here's a look at the bottom. It sure looks like you remove these 4 screws that are going through the feet, and that will loosen up the chassis. I pulled the 5 knobs off the front. The push button knobs stay with the chassis. But even when it's loosened up, I'm not sure how you get it out. To lift it straight, tilt and straight, because the knobs on the back are sticking out too. Unless maybe I have to pull those off, which, yeah, they're on there pretty good, but it might be how it goes. I was thinking maybe this back could come off, but no, that appears to be spot welded on. That perforated metal back, so that's not coming off. And the front doesn't come off, I don't think, either. Unless, maybe it does, maybe it does. There are 2 large screws on the front. Maybe the whole front comes off. Or maybe that's just holding the chassis in place too. There should be a screw on either side on the inside about here. It was present on this side, missing on that side. That's what was holding it up. Now it just comes off. Wow, that's heavy. That is some, I don't know if it's aluminum or steel, but that's pretty substantial. This should just come out. Rubber plastic gasket so we can get all that cleaned up. Put this aside. Now we can get a good look at this. These knobs are kind of odd looking. I wonder if they all had labels on them at some point. Some of them have, appears to be inserts and some don't. Okay, this side is crusty. I'll do what I can. I'll soak all these in warm detergent and clean them up. CRT, of course we want to hope that's good. Big old thick phenolic plate there. Ah, I see. I was wondering when this is numbered 3 through 12. And there are a couple more adjustments to that. There's a trimmer cap for setting each of these channels. It's a lot of trimmer caps from what I recall. There's 3 trimmer caps per channel. It's like aligning a radio. Oh, there we go. Chassis was just getting hung up on something. Well, it does say T-54 on this box in red. This apparatus uses inventions of United States patents licensed by the Radio Corporation of America and Hazeltine Research Inc. Patent numbers will be applied. Patent numbers will be supplied upon request. That's what I'm trying to say. Serial number HA, and then there's no serial number. Ugh. Kidding me. Ugh. So close. Stupid AC interlock has to be screwed from the cabinets. Just that easy. Let's try to zoom in on that chart there. Yeah, absolutely. Model T-54. There's our tube layout. Alright, let's get this out of the way and get the chassis up on the workbench. Let's take a peek at the schematic and see what that transformer is all about. Let's take a look at the weird power supply. Oh, could that just be a filter choke? Could that be L1? Maybe. So here's our power coming in. And yeah, the one side goes through a 2-amp fuse right to ground, which will be the chassis. So no bones about that. This is a hot chassis set. Other side, we have an 18 ohm resistor, and then we go off to 2 strings. Be 300 milliamp strings for the tubes. Then they join up. One of these will be the pitcher tube, and then what else might be a 600 milliamp tube? Maybe the 6X5. Anyways, as far as the power supply goes, we have a 6X5 full wave rectifier. We have a 25Z6 full wave rectifier. We have a selenium rectifier. We have 4 voltages coming out of this thing. I believe we have positive, negative, we have a doubler, we have a tripler. It's a little crazy. Oh, is that, maybe that is just a filter choke. Huh, well, it's L1. If we look at our parts placement diagram, let's see. Enjoy the crustiness of the chassis. Mostly I'm concerned about cleaning that out. So you have 3 rows of trimmer caps, 3 trimmers for every channel. Now luckily I probably just need to adjust this for channels 3 and 4. I'm not going through all of them. Or maybe they don't need any adjustment at all. Stranger things have happened. L1, yeah, that is just a filter choke. That big transformer looking thing up there. It's just a choke. Okay. Fine. So I don't see any corrosion, but boy, I sure do see a lot of dirt. Let's take a little exploratory clean. Oh, there's even some labels. Do not apply power to receiver with 6AL5 tube removed. I wonder why. Okay, we won't do that. But boy, this sure cleans up nice. Looks like somebody penciled in the tube numbers next to every tube. So wow, I guess the top is perforated. Yeah, so those perforated holes must have just let all this dirt filter in. But well, yes, if it wasn't 5 below outside, I'd take it out there and use a blower on it. But I can't, so I will use a little vacuum instead. But right now, let's get underneath, shall we? That looks beautiful. I think. This is very close to being all original. Pretty sure that's a replacement because they snapped the retaining ring. It would have originally looked like these, but this guy's been cut. This might also be a replacement. And maybe this guy, this solder connection looks a little crude down here. But otherwise, yeah, and it's very similar to the one that I worked on too. I think I remember these caps. Grudeman, Grudeman company, capacitors. You know, I don't think I've ever seen those in anything else. I mean, that might have been what they used in their communication receivers. Also a few caps are the Industrial Condenser Corporation. When I did my 506, I restuffed all the caps, and a couple that weren't original, I fabricated new labels and everything. I'm not going to go to those lengths here. We don't even have all the original caps. But anyways, this is what I really wanted to take a look at, is up in this corner. This is what I wanted to confirm. See, I've worked on a lot of electrostatic TVs, and the standard capacitor values are, for the high voltage caps, Let me take a step back. Typically these run around 5,000 volts or so, and they will use capacitors to couple the horizontal and vertical deflection signals to the CRT. And typically for the horizontal they use 0.001 or 1,000 picofarad 6,000 volt caps. And for the vertical they use 5,000 picofarad 6,000 volt caps. The service info said 0.03 or 30,000 picofarad for the vertical caps. And in here, what do we see? We see 0.05s, even bigger. I don't think they need to be that big. The reason I use big caps for the vertical is this needs to be a very, very linear sawtooth waveform. It's going to be several hundred volts in amplitude. They need to couple it from the vertical output tube to the deflection plates with no distortion. If you use too small a value capacitor, it's going to distort that sawtooth wave. But like I said, just about every other set I've ever worked on, the Motorola's, the Admirals, I use 5,000 picofarad. This is 10 times that. I can get them, I think, but they ain't going to be cheap. Not if I get axial like this. And then for the horizontal, it said it used 500 picofarad. But I can see one right here, and it's 1,000 picofarad, and this is probably the other one. I think these might have been replaced. Now that's a 5,000. I think that's been a replacement. So I think several of these have been replaced, maybe all of them, and maybe they used what they had on hand. So Aerovox, a Sprague, Cornell Dublier, they're all different companies. This is a Motorola. So all four are different manufacturers. That never would have happened when they made this. They would have gotten them from the same place. So possibly all four of these have been replaced. It's really, really, really common for these to go bad. They're always bad nowadays, but I'm not surprised that they failed back then. So probably the service info is correct. I'll probably go with 1,000 on these just because that's what I stock and that's what they typically use. But for these, okay, fine. I will try to dig up something much larger. These are some really crummy electrolytic caps up here. They're the paper cardboard kind, so they tend to really dry out because they're not in an aluminum can. Looks like we got a 2-section here, a 30 and a 60, 450 and 300 volts. I can't even tell the sections. It's a 3200 and a 3200. Maybe something else. I got 4 wires. Maybe a replacement. It's really badly in there. And this is also a couple. So we have 2 caps in that one, 3 caps in that one, 2 caps in this guy. In other words, there are no twist lock electrolytics in this. These are all the electrolytics right here. They're all like that, which is a challenge in terms of replacing them. Terminal strips, yeah, I'm not going to use an adapter cap or anything. There's nowhere I can't. The CRT is directly above this. There's actually the chassis bows out down here. There's a depression to accommodate the CRT. So, anyways, this is what I wanted to triage or initially chuck this out. Is I'm going to see what it uses some unusual parts that I'm going to have to source and figure out a plan of attack as far as how am I going to do. So, absolutely, it's different, it's weird, but it's actually pretty easy to work on as TVs go. It's really spread out, very easy to get at all the caps. Just clip, replace, clip, replace, clip, replace. Not even any twist locks to deal with. On the flip side, if you do have problems because it's so weird, it can be tough to source parts, can be tough to troubleshoot, but we'll get through it. Honestly, my gut reaction is the main hassle is going to be cleaning it and lubing and getting these all freed up and working properly, and tracking down some of these oddball parts. I'm not going to try powering it up. I don't see really any point to that. These caps look kind of sketchy. But let's wrap up with testing the CRT. And then I'm going to hop online and try to track down some of these parts. Word of warning. With this out of the cabinet, this CRT is completely unsupported. I'm lucky nothing bad happened when I was turning this around. It's only connected to the base right now, which we are going to very carefully, gingerly pry out. Gentle pressure. Flat-bladed screwdriver. Just work our way around, loosen it up. That's good. Then I can just remove it while I'm working on this. Make things a little easier, I think. There we go. It's going to be a little tricky to get out because there's 14 spots for pins 2 are unused, so there's 12 pins on the base of this guy. Let's see, it's an RCA. Yeah, I think I encounter more RCAs than any others. Getter's good and shiny. Said this so many times, I'll say it again. The only true test of these CRTs is in a working set, but a tester will certainly tell you if the filament's good or if there's a short. And if we're lucky, we can see a little splotch of light on the face of the CRT while we're testing it. So, tip this up and out of the way. And get my tester out here. Okay, here we go. Let's go to filament set. Turn it on. 6.3. Yep, it's glowing. And let's check for HK shorts. We are good. G1 shorts. We are good. Cut off. Yeah, we don't have any cutoff control. We do have emissions. Oh, now we have cutoff control. I just needed to be patient. Well, it certainly tests really good, but I've seen that time and time again. Doesn't mean anything because the phosphor can degrade on these. So that's one last thing we can do. We turn off our lights, and I'll flip the CRT up. It's in test mode. Let's see. Yes. Whoa. I hope the camera caught that. I'm not sure. Test light fell off. I'll try to reconnect it here. Hold it on there. Right, you see that splotch of light? That's a very good sign. It will definitely produce an image. That's guaranteed. How bright, how sharp, how crisp, don't know, but good enough for me. We'll proceed. Alright, that is going to be it for now. I am going to start tracking down these parts, and we will pick up in the next installment when I got a pile of new parts and we can start recapping this puppy. I will also start cleaning it off camera. You don't need to see me vacuum up dust. That's it for now. Thanks for watching.